Hi, this is Mr. McGovern, and this is the third video in the Unbalanced Forces series, where we're going to do a calculation, show you how to do calculations in these, and use an example for that. So let's just tell you what the example is first, then we'll show you how to do it. So the example is similar to the video I had in an earlier video where we had some people pulling on ropes on either side of a cart, which will cause the cart to accelerate. So there's a blue team and a red team. So the left force, so that's the blue team, is 500 newtons. The right force, which is the red team, is 600 newtons. The trolley's mass is 200 kg, and if it starts from rest, what distance has it travelled after 5 seconds? So with this type of situation, really what you're thinking about is you're thinking about two ideas in physics that are linked. The first idea is the idea of forces. Okay, for forces, we need a coordinate system. We need that so we can identify which is positive and which is negative forces. We need a force diagram, and then using that force diagram we can work out the total force, and you do a calculation to work out acceleration. The second physics idea we're thinking about is the equations of motion. So that's acceleration. We need a coordinate system for that so we can tell what's positive and what's negative in terms of the velocities and the accelerations, and then we need to choose a equation of motion. So one that you've seen before is Vf equals Vi plus At. Linking those two ideas, forces and equations of motion, is A, acceleration. So you'll see in the forces box is total force equals ma, acceleration. That's the same acceleration that turns up in the equations of motion. So you might start by working out the forces, so you could work your way through this box to work out the acceleration, use that acceleration to use an equation of motion, or they might get you to work backwards, where you've got some information about the equation of motion. You can work out acceleration and use that to go back into a force situation and work out forces if you need to. So let's use this idea to calculate what this question is asking us. So it's asking us, it's given us some forces, the mass of the trolley, it starts from rest, what distance has it travelled? Okay, so we start with the coordinate system. In both cases, the forces and the equations of motion, we need a coordinate system. I've chosen right to be positive. The reason I've chosen right to be positive is because the right force is larger and the cart's going to accelerate that way. So it's accelerating, which means its velocity is getting bigger. Its acceleration is the difference in velocities, and they are both pointing to the right. And in one of the earlier videos, I really stressed that the way the acceleration points is the way the net force points. So that'll make sense. So we've chosen right to be our positive direction. Right, so let's go with our force diagram. So we have a downwards force on the cart. We're just thinking about the cart here from the earth, and upwards force, the normal force. The cart's not accelerating up or down, so those two are equal and balance each other out. We've got our horizontal forces from the blue team and from the red team, and the red one is larger than the blue one, and we can actually put numbers on that because they give it to us in the question. 600 newtons pulling to the right, and 500 newtons to the left. Now, our coordinate system, remember, we chose right to be positive. So that means our left force is a negative force because that's the negative direction. So when we find our total forces, this will make sense. So we've got our total force equals ma. We want to find acceleration because that's what links forces in the equations of motion, is total force over m. The total force, whenever you total something, you add them together. So if you want to work out the total money you've got, you add all your money up. The total number of people in a classroom, you add all the people up. So I'm going to add the forces. I'm going to add 600, and I'm going to add negative 500. Okay? So that's where the negative comes in. It's really important. So 600 plus negative 500 is 100 newtons divided by the mass, and we work out the acceleration is 0.5. Remember, that acceleration links this idea of forces with the equations of motion. So I've found out an acceleration of 0.5 using my forces. That's the same acceleration that will sit with my equations of motion. So now let's use those equations of motion. Here they all are from your formula sheet. This is now an exercise, once you know this is what you're going to do, in choosing the right formula. So then I write down what I know. So I know the acceleration is 0.5. The initial velocity is 0 because it says that the cart starts from rest. The time it goes for is 5 seconds, and I want to find the distance it travels. So those are my 4 variables, and I look for a formula that has those 4 variables in it. It just happens to be the first one in this case. So I'll start writing that down and substituting things in. Often with this first one, you're lucky, not all the time, but often, where an initial velocity is 0. And 0 times the time, 5 seconds, simplifies out quite nicely. So do the calculation here and you get a distance of 6.25 meters. So once again, this was about linking the equations of motion with forces.